All right. In part one of our topic directed numbers, we look at basically the definition of directed numbers. So now we will continue. There are things we need to explore. One, sometimes directed numbers are referred to as integers. Integers. Directed numbers are sometimes referred to as integers. All right. So when we talk of these integers, okay, we basically are talking about say uh, say -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on and so on, right? So if we have this set of integers, that means when you see this sign, it means there is no beginning. When you see this one, it means there is no ending. So this is an infinite set, an infinite set, a set of numbers without ending, without beginning in this regard. Okay? Now, there are three important categories of this set that I want us to remember. Okay? Which I want us to remember. One, uh, we have 0. We have 0 here. Okay? That is very important. 0 is very important component here. Now, apart from 0, what do we have? What do we have apart from 0? Apart from 0, we have the right hand side, numbers which appear on the right hand side. These ones. Okay? Okay? Numbers which appear on the right hand side of 0. And these numbers are positive. Okay? They are positive. Okay? So a symbol for positive is plus. Okay? Now, we also have another component, the third last. Okay? This numbers which appear on the left hand side of 0. This one. These ones are negative numbers. They are negative numbers. All right. So the symbol for negative numbers is a negative sign. All right. With that one, I think we are dusted. Okay. We are done and dusted. Everyone understands the three components of integers or directed numbers. We looked at them in our part one of this paper. So in this part of the paper, this one is a prerequisite knowledge, a foundational knowledge. All right. Now let's get to our today's business now. What I want us to look at now is um, distinguishing directed numbers with respect to their being the greatest or the smallest. All right, the greatest or the smallest. So let's say you are asked to tell whether -5, you have -5 and +5, and the question is which one is the greatest? What would you say? Which one is the greatest? Now, remember that negative numbers are smaller than positive numbers. Negative numbers are smaller than positive numbers. All right? What I want to tell you today is that positive means increase. When you see positive, you must know that it means increase. When you see negative, negative means decrease or reduce. Okay? Now, that means when you decrease a number, you make it smaller. When you increase a number, you make it larger. All right? Now, when you have -5 and +5, you must know, all right? You must know that this one positive number is greater. So we will say -5 is less than +5. That's what I want us to understand. Okay? Okay. Let's see this one. Let's see this one now. Let's see this one. Let's say you have 2, and then you have 2, and you have -4. Which one is greater? Which one is smaller? Okay? What do you do? What do you do? You just have to remember, one, negative is smaller than positive. So whether this is 4 here and this is 2, and seemingly you may think that 4 is greater than 2, but because there is a negative sign, you need to remember that a negative number is always smaller than a positive number. So that says this 2 is greater than -4. Ta-da! Someone is surprised here. +2 is greater than -4. Why? Because a negative number is always smaller than a positive number. Okay, let's write this golden rule here. Let's write this golden rule here, right? Nota bene, it's a golden rule, this one. Nota bene, note well. It says negative number a negative number is always less than a positive number. This is our golden rule, okay? A negative number is always less than a positive number, okay? So now we have the signs which I want us to look at. We have this sign in mathematics and this one, okay? So this sign is referred to as less than, is less than. When you see this sign, it means it's less than. And this one is greater than. Okay? So when you see this statement, this mathematical statement, it says -5 is less than +5. All right? And this statement says 2 or +2 is greater than -4. Okay? Now, let's continue. Let me say you have -100 and you have 0. And the question is, which one is greater? I got your. Which one is greater? -100 and 0. Now, the problem here is that 0 is neither negative nor positive. So this golden rule here is not relevant here. Okay? Now, what do we do? What do we do when we have this case? If this number had been positive, let's say we had -100 and then we had +1 here, it would be better because our golden rule would apply. Okay? We would say a positive number is always greater than a negative number. Therefore, we would argue arithmetically, we would argue -100 is less than +1. Okay? But when it's 0, what do you do? Oh, surprise, surprise. Negative 100 is less than 0. Why? Because negative 100 would appear on the left hand side. On the left hand side of 0, because negative numbers are on the left hand. So length of 0 is less than 0. And any number that appears on the right hand side of 0 is greater than 0. Now, we want to polish up our golden rule. A number, when you compare two numbers, a number on the left hand side is smaller than a number on the right hand side. Okay. A number on the left hand side of the number line, a number on the left hand side is always smaller than a number on the right hand side. So as far as integers are concerned, left means smaller, right means greater. Woo! So you get it now. Okay, now that means if you have 5 and you have 8, the question should be, is 5 on the left hand side or on the right hand side of 8? So if 5 is on the left hand side of 8 on the number line, okay? Okay? That means 5 is smaller than 8, like this. All right? So let's say we have 150, we have 100. Which one is smaller? 150 appears on the right hand side of 100. 100 appears on the left hand side of 150. So that means 150 is greater than 100. So when you are dealing with integers and you are trying to arrange them in order of size, you need to bear in mind that the number which appears on the left hand side is smaller than the one that appears on the right hand side when you are comparing two numbers. Okay, now let's take, for instance, and let's look at an example that could be asked by examiners. Let's say you are given a list of numbers, and a list of numbers like positive 5, okay, negative 4, positive 3, negative 3, then 0. And the question is, which number is the smallest integer? Which one is the smallest integer? Which one is the smallest integer amongst these 5 integers? Okay, which one is the smallest? Okay, smallest is equal to what? Smallest is negative 4. Why? Because if you would write them in order of size, we would have negative 4, negative 3, okay? We would have what? 0, okay? Positive 3, positive 5. This is this list in order, all right? Now you can see that negative 4 appears on the left hand side, the further left. It's here, okay? It's here. Now, since positive 5 appears on the further right hand side, then it's the greatest number, the greatest integer. All right? So this actually answers the question. The smallest integer, the greatest integer. So if you have a problem with identifying the smallest or the greatest integer, first of all, rearrange them in order of size. Then the one that will appear on the left hand side is the smallest. The one that appears on the right hand side is the greatest. All right? Now, let's continue and look at another example. Uh, you are asked to find the smallest and the greatest integers in this one. Okay, so we have this one, -3, -2, +2, +6, -7, -9. Okay? Now, you are asked to find the greatest integer, and then uh, the smallest integer. The greatest integer and the smallest integer. Which one is the greatest integer here? By inspection, I see +6. All right? +6. All right? Which one is the smallest integer here? By inspection, I see -9. So for some of us, it's still not easy to understand why, unless we rearrange these integers in order of size. So the smallest would be -9, okay, -7, -3, -2, all right, then +2, +6. This is orderly arrangement of these integers. All right. Now, when you look at these integers arranged in order of size, you are aware that at this left-hand side we have -9. Now -9 becomes the smallest integer. Okay. On the right-hand side here we have +6. So +6 becomes the greatest integer amongst these ones. All right. So that's as easy as that. So don't ever be confused. Don't ever be confused. All right. Now, 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 let me just take the last example in this regard. Let's say we have this one here. Let's say we have this one, +5, okay, 0, -4, -3, +2, all right, -2. Which one is the smallest and which one is the greatest integer? Which one is the smallest and which one is the greatest integer here? One, the greatest equals 1. Which one? It's 5, +5. Now the smallest equals the smallest is equal to what? The smallest is equal to -4. You can arrange them in order. I see this one and this one. You can arrange them in order of size if you want to use this approach. Okay? It doesn't matter. Now, let's look at the last two examples on a different subtopic. We have done this in our examples, but I want us to hammer on it so that you understand it. Now, uh, uh, you have a question that says, uh, complete the statement by putting in this or this. Is less than or is greater than. is less than or is greater than. So you have A, you have -9, +3. B, you have -13, +13. C, you have 8, which is positive. You have -15. So can you complete these mathematical expressions using this, or mathematical statements using less than, is less than, or is greater than? Now, what you do here, you just have to relax and remember what we discussed. Okay. Now, what is happening here is that you just have to tell whether -9, okay, between -9 and +3, which one is greater, which one is smaller. So if this is smaller, then you are going to say is smaller than. You are going to say -9 is smaller than +3. Okay. Between this and this one is smaller. So you are going to say -13 is smaller than +13. All right. Between +8 and -15, which one is greater, or which one is smaller? This one is smaller. When we start from this side, +8 is greater than -15. So greater is this one. We're going to say +8 is greater than -15. Dada, then you are correct. Okay? With this, I would just assume that at least now you have a glimpse of where we are going with directed numbers. Here, I just wanted to give you the definition of directed numbers according to the three components, being positive, zero, negative numbers. Okay. Now, and then we tried to make sure that at least you can know, or you can tell which one is smaller or greater if you are given, say, two integers. You must be able to distinguish them in terms of their greatness or their being smaller. All right. Now we will meet again in our next lesson, and I believe our next presentation uh, is going to be profitable to you. All right. Take care.